Okay. Yeah. I'm going to present you this graph and another one. Howdy, it's me. I like to discuss a topic or make a statement, and in this case got nothing to do with Bible and science, but I like to make a statement, which I yesterday discovered, and I thought, hey, that's remarkable. So I don't know if it's true, but it's just a thought. It might be true, I don't know. That's maybe up to for testing and finding out if it's true what I'm going to state right now. So it's just an idea what I wanted to share. Maybe it's true, maybe it's not true, but I'd like to state it anyhow. Okay, it's about this graph, and this graph made me think about it. These are actually real measurements. It doesn't matter about what. It's just a quantity, but I'm not making fun. This is this graph, and all the graphs I'm going to show you are based on real measurements. Trust me on this one, and if you don't trust me, well, that's your problem. But I'm stating this is real measurements. As you can see here, that there's a quantity measured, and with certain this is measured about 200 times, a little less than 200 times, 194 times. The same quantity has been measured over and over again. And this is the graph that appears from it if you would try to construct it in a Gaussian type of curve. This is what you get. And here the actual measurements, or the averages of it, the progressing average. And you see 194 measurements have been taken. This is the graph what you get. And it occurred to me that our measurements, and if you put them together like a Gaussian type of curve, that you get a thing like this. But it occurred to me that actually our measurements, our observations, even the observations might behave like a wave function. As you can here see, if a wave function is the adding summation of more than one sinus and cosinus thing, and you add them all up together, and then you get some kind of wave function. And well, yesterday it occurred to me from, hey, even our measurements may be constructed as a wave function. This is the other graphs which I want to put across, which also, these are actually. The other one, the other graph I showed you was about little less than 200 measurements. This graph is made actually from thousands and thousands of measurement data points. And this is a real graph. I measured this in a laboratory, and it doesn't matter what laboratory, and it doesn't matter what parameter. I can assure you that this is a trustworthy measurement on laboratory instruments. But what you see is, you don't need to doubt about that. I know it's true. What you see is also a wavy type of pattern appearing in the measurements if you put them together like a statistical graph, as you expect. What I try to do is with this data, the blue line is the actually measured data in a way that you try to construct a Gaussian curve. Well, okay, this real graph gives you an average, and it gives you a standard deviation. And based on that average and standard deviation, this theoretical green curve was constructed. Well, you see, they don't match. Only maybe here and only maybe there, but not where it's most important in this area. It doesn't match. What you see is actually a wavy type of curve, and also the other one, the one that I showed you in this thing, it's a little bit wavy. Also here you get a little wavy thing, and that made me think that actually our observations behave like quantum mechanical wave functions. And I got some more curves where you can see it more clearly. For example, this this curve is also another parameter, really measured parameter, thousands of measurements, and also here you see a wavy type of behavior. And you can also see it. I have this curve, and based on this curve I derived an average and a standard deviation from it, and based on that deviation, based on that average and the standard deviation, I constructed this light blue line, which is the theoretical thing you would get if the theory and practice match together, but they don't. As you can see, they don't match together. So you can calculate an average, that's what you always can do, and you can calculate a standard deviation, assuming that the real measurements have a Gaussian type of curve, but they don't. So you see the practical measurements are deviating from the theoretical curves. Well, what I also try to do is what you can also do is make a tilted Gaussian curve, well, in this case to this side, and that's the purple line, which matches better than the light blue line, but still the actually factual measurements are waving around the theoretical tilted Gaussian curve. I think the tilted Gaussian curve, they call it Poisson curve, and you got some other terms and some other guys who made up some formulas to calculate that. And but what you see is that it is waving around the theoretical curves, which made me think. Yesterday I happened to construct this curve, and from a certain moment on, it appeared to me from, hey, it shows that it seems as though these it's not a theoretical Gaussian curve. No, it's a tilted one, and not only that, but they show a kind of waviness. And so that made me think from, hey, maybe our observations. One moment, I'll zoom out so you can see me as well. Hey, come on, boy. Then I'll zoom out in this way. So, okay. So that made me think that even our observations might be subdued to the rules of quantum mechanical things, and being actually wave function or type of wave functions, as I try to make put across here. I don't know if I'm right, but that occurred to me from, hey, even our observations might behave like wave functions, quantum mechanical wave functions. Wave function is if you start adding up all kinds of sinuses and cosinuses in with all kinds of wavelengths, etc. You add them up together, and then you have, for example, with positioning an electron. They assume that it's a wave, and all the wave patterns you add up, and then there appears a spike, a Gaussian curve like spike, and that's the reason why I came up with this idea. But hey, they resemble. From quantum mechanics, I knew this, that the position of an electron, or in general a particle, you can calculate based on wave functions. And a Gaussian curve appears also like a wave function. That made me add one and one up together to become two. So that's what I wanted to share. Don't know if it's actually correct, but this is what I wanted to share with you. Okay, hasta la basta.